we're going to start talking about a new quantity that is called the resistance. So the electrical resistance has a symbol R. So R is the resistance. And this will be given in a unit that is called the ohms. And this is the symbol for the. So we already said that the current, so the current is given by, so again, if you take, so as an example here, if you take a copper, and then we're going to connect it to the body like this, such that this is my plus and this is my minus. So because this is plus and this is minus, you have an electric field that is pointing in this direction. And so the electric field is going to move positive charges from this point to this point. And so you're going to have a current. So there's a current that is flowing, I. And that current is given by this equation right here. So sometimes what we can do is that we can introduce this quantity that is called J. So J is the current divided by the area, which is given by this equation here. And we can write J by this, where in this case, my sigma is just given by N times Q. And this is called the electrical conductivity. So again, I can write, I know that because the electric field here is just a uniform electric field, it means that the change in voltage between this point and this point is given by this equation here. And so if you go ahead and just, you can write the delta V by that. And if you rearrange this equation a little bit, you end up with this final equation right here. So the resistance is given by the change in the voltage divided by the current. So the way this is going to work is that, again, you don't need to worry about all these derivations here. You just need to focus on this equation here. And this equation is called the Ohm's law. Ohm's law. Now, so you have, so on this picture here, you can see different types of, so these are types of resistors. And for every resistor, it has something that is called the color code. And the color code gives me an equation that I can use to calculate the value of my resistance. So for example, if I have a resistor that has, let's say, so you can see those lines, if you see those lines there. So for example, if the first one is red, maybe the second one is black, and then the third one is maybe something like blue, then I need to take those numbers here. So the number here would be, so if the first one is red, then it means that the first value is 2. And then the C1, so C1 is the first quantity here, and C2 is just this multiplier that comes from this table. Again, as I said, the main thing is that each time that you have a resistor, you can tell what the value of the resistance is going to be. And if you know what the value of that resistance is, then you can calculate your current. So let me go ahead and share one example here. So let me share one example here where we're going to calculate. So in this example here, we're going to calculate current. So we're going to calculate current. So current through a resistor. As I said before, so a resistor looks like this. So that's the symbol. And so for the circuit is going to look like this. This is going to be my delta V. So let's take delta V as 10 volt. And let's take the value of this resistor here to be equals to 100 ohms. And then let's look at the second resistor here. Now this is 1,000 ohms. And we get my delta V here. So what I want to do is that I want to calculate how much amount of current I, so this is my plus and this is my minus, this is plus and this is minus. So I want to calculate how much amount of current is going to flow in this system. So again, we have this equation here that tells me that the resistance is equals to delta V divided by I. So solving this equation, I get I is equals to delta V divided by R. So it means that if this is part A and this is my part B, so for part A, I can calculate my current as my delta V, which is 10 divided by R. And this will just be 0.1 amps. So the current is measured in amps. And for part B, when I calculate the current, I take the value of the voltage and I divide that by the value of the resistance. So this would be 0.01 amps. So you can see that. So what you can see is that so the larger the value, the smaller the current. So again, if you think about this in terms of the physics of the problem, again, let me try to explain, because I think it's very, very important to understand. So let me go back here and open a new. So this is what we have. So this is the 100 ohms resistor. And this is a 1,000 ohms resistor. So I'm saying that if I take if I take this and connect it to a 10 volt, Then here I get a current of 0.1 amps. Here I get a current of 0.01 amps. So what does this mean? So this means that when I take a look at this resistor here, so again, so when I look inside the resistor, this is what I'm going to see. So I see that. So you can see that these electrons are loosely bound. So because the electrons are loosely bound, it means that you can so the electrons can easily move in the presence of an applied voltage. So this is the applied. Now let's look at the 1000 ohm resistor. So for the 1000 ohm resistor here, you see that the electrons are the electrons are tightly bound. So I have electrons that are more tightly bound here. So this is tightly bound. So it means that it requires more energy so it takes more energy to create a current. All right, so that's one example. Let me solve a second example here. Now, in this example, suppose that we have something that looks like this. And let's say that this is 100 ohms. This is 10 volt. And we know that here the current is going to be equals to 0.1 amps. Now, suppose that we have something that looks like this. Let's say this is 500 ohms. So the question is, so what voltage what delta V should be applied to 500 ohm resistor to produce a current of 0.1 amps.